Hello, this is A squared at mathandstuff.com. This video may be reached with other videos at mathandstuff.com on video. It will be posted here on video of how to construct a hexagon. You could also go to the definition of hexagon or to other pages on which it will be used. The topic at hand is the construction of a hexagon or a triangle. The purpose is talking about angle measures, and I wish to talk about the historical point of view, but I'll just deal with hexagons now. To make a hexagon, an equilateral hexagon, I'm going to start with a circle. I'm going to move it so I can work on it. I started by clicking the center first and then dragging the circle out to a point. So I made a radius. Doesn't matter what it is, but it's done. I'm now going to do it backwards. I want another circle. Here's the new center, and I go to the old center. I now have two circles, two concentric circles. Notice that the circles intersect at 2 points. So I'm going to click each circle, and I'm going to construct intersections. I really have all I need now to construct an equilateral triangle. I'm just going to show you that, and I'm going to erase it because I don't wish to do that. But I promised I would. So there's an equilateral triangle. I'm going to get rid of that. I don't need that. I want to talk about the fact that the triangle is the most basic polynomial. And if you go to places like Göbekli Tepe, or even Stonehenge, which is much younger, you'll see that circles were important to the ancients. If you see what I have here, compass is modern day and used on paper. I think they just used a rope and swung it with one or two people. And you don't even need a straight edge. You don't even need a ruler. All you need is a rope held taut, and that will give you the abilities to make a straight line. But we want a little more than that. We want to divide the circle. This is really beautiful. I want to create another circle. I want that to be the center. I want that to be a new radius. I'm going to construct the intersection. I'm now going to use Circle Maker again. I made another circle. I now want another intersection. I'm now going to make another circle. Nope, I need to go where? Here. Nope. Where do I need to go? I need to go here. It's important to choose your center. There you go. Center comes first. Then you mark the intersection. And if you look at what you have, and I'm going to erase these. I'm just going to save the file. You really have. Let's mark it. Let's pick a color. No, let's mark it their way. 1, 2, 3, 4, 5, 6. 6 congruent segments, congruent arcs all around the circle. I'm going to get rid of those. And I'm going to go back to my original task, which was to draw the hexagon. Let's make it color. Nope, got to start drawing first. And I want to make a bunch of sides for the hexagon. 1, 2, 3, 4, 5, 6. I'm going to save it again. I really like to hide the circles. I'm just going to mark this point. And I'm going to attempt, I'm going to attempt to hide the circles. There we go. There's the hexagon finished. I could mark it with the angle measures, but I'm not going to bother. But I will point out that the hexagon is formed with 6 triangles. The sum of the central angles, when they're placed like this, is 360 degrees. I bet you heard that number before. I've included notes on how one would do it with a compass or a rope. And here's a link to where the video will be posted. I'd like to talk a little more. If you don't want to hear this, you don't need to. The purpose of the video was to really talk about a round compared to a cross. Now, what do I mean by that? I want to go to the website. I'll go to mathandstuff.com. Okay, I can't find it. I'll go to words. There we go. Let's look at pi. Pi by definition is the ratio, that means a fraction. You don't know what ratio is, Here you go. You could look it up. Of the compared to the circumference. In other words, around divided by across. I don't think we need this. Let's go back to here. Okay, if you make just a triangle, and you can easily do that, you'll see why it's not in this list or table of polygons. A triangle does not have a diagonal, does not have an across. So, though it is the most basic shape, doesn't have a diagonal, so you can't compute across. For a square, a regular quadrilateral, you can compute around compared to across, and you get 2.8 something. If you wish to do it for a hexagon, around is 6, because we know we had 1, 2, 3, 4, 5, 6 sides. And across, you just go across on a diagonal, the longest one, and that's 2. So we have around is for this particular one, and I could change it. I could change the sign, but I'll still get the same ratio, the same circumference. It's 3. And for the Hebrews and the Sumerians, 3 was good enough. And you can see that by 360 degrees in a complete rotation. For 6, it's 3. For 8, it's 3.06. For 12, it's 3.1. For 16, it's 3.12. Enough of that. Later, I will use the shapes for a circumscribed and an inscribed hexagon. And here's the instructions for doing what we did here. That's all I have for you today. Have a lovely day. I hope you got something out of this.